Roll. All right. Let me show you why I gave you
Wow. So you weren't even just being nice. This is for a lesson.
Okay, so a lot of teachers.
Wow.
Oh, you know at Walmart they be opening up those things, licking them, and putting them back in.
It might have been my driver. I just did Walmart delivery for Walmart. All right. So here's why we did it. When we take derivatives of functions in functions. By the way, what do we call like a function in a function?
Function is a function.
A double function.
What's a composite function? You're exactly right. Good job. There's a function that sits within another function. For example, maybe something like 3x squared plus 1 squared. That's a composite function, yes? The outermost function is x squared. The innermost is 3x squared plus 1. Do you see that? There's two different functions going on here. So, let's see, blood pop, we're going to have to work our way through the outer shell to make it to the middle. Whenever we get a little further with chain roll, we'll have multiple layers. I don't have a candy for that. Some teachers use those brush and nesting. Oh, that is a good idea. Yeah. Okay, so here's what chain rule does. What we have to do if we were to take the derivative here, we do the derivative of the outside, and whenever I say derivative of the outside, this is where y'all always wanted to use power rule. In this case, we leave the inside alone when we do that, okay? So here, 2 times, I leave that inside alone. Now you are, because now you know chain rule. And then I have to take the derivative of the inside. And what I'm going to do is keep working my way in until I've taken the derivative of every layer of function in there. So here, times, and then I take the derivative of what's inside. So what's the derivative of what's inside here? 6x. So the derivative of f of x here, unless you okay. So the overall derivative here would be 12x times 3x squared plus 1. This takes some getting used to, but you will start this. The derivative of the inside there, yeah. When you do chain rule, that's what you have to do. So you do power rule on the outside, or you take the derivative of the furthest outside, and you leave the inside alone. So really what you're doing, if you've got f of g of x, is you're doing f prime, and you're leaving g of x in for x, and then you're multiplying by the derivative of the inside. Does that make sense? Sometimes you might want to write that down. Sometimes they give you a question that looks something like that. Showing you that, that you do the derivative of the outside function first. So determine what's the outside function, what's the inside function. Let me show you one that's a little bit No, not unless there was a reason for you, like it was a multiple choice and you had to. Second, I'd probably distribute if it was second derivative. And do power rule on each particular one. No, he's not here today. I know. He texted me. He texted me and said y'all were complaining about calculus to him at the football game. No, he didn't. What? Find the derivative.
Negative sign of.
So the derivative of cosine is negative sine, but I can't do just negative sine x, right? Do you see the two functions within each other here? I've got the cosine and then I've got the x squared plus 1. So I need to start furthest outside. You got to eat the shell before you can eat the bubble gum, right? So before I can take the derivative of this, I got to take the derivative of the outside. What? It's an illustration. Can't wait till I hear a sermon of yours with an illustration in it. Another one, now that you've picked on me. All right, derivative here. Derivative of cosine would be negative sine, right? And I leave the inside alone. Don't bother it. Now take the derivative by 2x. That's exactly right. Now this 2x is not with this. This is a part of an argument of sine. So I'm going to bring it around front just so I don't get confused as to what I'm finding. It's easy. It's just easy to forget to do it. Yeah. Yes, you could. You could have a double chain, a triple chain. You could have, yeah. Let's try another one. Y'all say this is easy. How many functions do you see here? 3. I see 3.
5.
I see tangent of something. That's 1. I see 5 minus sine 2t. That's something else. Then I see sine 2t. That's a third. Does everybody see that? All right. So starting from the furthest outside and working my way in. Tell me the derivative. All right. So the derivative of tangent is secant squared. Yes. Everybody agree? Did y'all remember that? Wyatt remembered. Did y'all? Okay. Oh, yeah. Yeah. At least those basic ones. All right. Secant squared, and I leave the inside alone. Yes? Say yes, because that's right. We always do derivative of the outside and work our way in, but we leave the inside alone as we do it. So now I need the derivative of the inside. Negative cosine, and I leave this alone. Whoa. Am I done? No, that's exactly right. Now I've got the derivative of 2t, which is 2. So now I got to clean everything up and put it kind of together and see what I got. I've got a negative and a 2, so I'm going to put those in the front. Negative 2. Let's see. Okay, but do they cancel out? Not just that, but look at the argument on them. Yes, I could make that 1 over cosine, but I can't cancel them out because this would be the cosine of all of this, and this is the cosine of 2t. In order to cancel those out, those arguments would have to be the same also. Do y'all understand what I'm saying? It wasn't subtraction, it was just negative, and since this is multiplication, the derivative of the 2t right here. Glasses. Thanks. We're just chain rolling, not just today, but probably for 2 or 3 days. We're chain rolling. An object moves along the x-axis. An object moves along the x-axis so that its position at any time is given by what is the initial position? Time is 0 at initial position. You plug 0 in. Whatever cosine, not cosine of 0, but cosine of 1, right? Cosine of 1. All right, what is the velocity at any point in time? The derivative, well, what is it? Which is? So I do the derivative here of cosine, right? That's the outermost, so negative sine, and I leave the inside completely alone. And now do the derivative of inside, which is, can I multiply the 2t with this parentheses? No, that parentheses is the argument of sine. That's the sine of bleh. This 2t is going to go in the front. What, bleh? Oh. It's just pretty math. You don't have to, just don't let it confuse you if you have to plug something in. Yeah, we'll do it. While I'm here, though, before I do acceleration, what if I asked you for displacement over the first, we're not going to actually do it over the first 5 seconds, because several of you, all right, so displacement means how far off from where I started I ended up, right? A lot of you on your test said, Ms. McGee, what is displacement? Oh, my heart. You plug in 0 in position. That tells me where I started, right? And then I plug in 5 to tell me where I ended up. Now, in between all of that, I could have gone shoop, 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 shoop. But all I care about with displacement is where I started as opposed to where I ended. And that difference is displacement.
Actually, does velocity like before you do the inside derivative or like after? Like the final one's velocity or the one where you run velocity?
Either one, they're the same thing. I just because I'm fixing to find the second derivative of it, and so it was easier for me if I put it all together and explained it up with it. All right, acceleration. How do you do that? By the way, somebody, and I don't even know who it was, I have your green sheet from Friday. Also wrote in pencil on top of it, SFP as final people. Do not tell me, because I don't even want to know. Just, huh?
Well, she knows who.
No, I really don't. One of my second blocks said, Miss McGee, somebody left this here and brought it. All right. If I need to find the derivative here, that's very. If I need to find the derivative here of velocity to find acceleration, what do you notice? Okay, yes, but they're not embedded. There's two functions embedded. Good job, Emma. She got it before you. You got the product rule. Look what I'm doing here. I'm multiplying. Do you see it? I'm showing you this because I want you to see the difference in. Yeah. I want you to see the difference in product rule and chain rule. There's still two functions here, but it's not a composed function. It's not a function embedded in another function. Like, yeah, we are. Okay, so derivative of the first, -2, times the second, plus the first. That's where y'all tell me what the first is. -2t. Oops. What? Only the co's are negative when you take the derivative. So the derivative. Cosine t squared plus 1. That's derivative of the second. Am I done? No. I got to chain it, right? I got to get to the bubble gum because, look, it's a function within a function. So I did here's what you got to think about. Whenever I do the derivative of sine, this is all the derivative of sine t squared plus 1. So I did the trig, and now I do the inside. What's the derivative of t squared plus 1? Yep, that's it. No biggie. Denny? Like Beckley? Oh my gosh.
Like, whatever we learned that class on total.
I gotta learn that.
Economics and personal finance.
Yeah, buddy. Yeah, buddy.
How many functions do you see?
3.
I see 3 as well.
I'm better than all y'all.
How many embedded functions do I see? 3 embedded functions, and you're right. So it's something squared, that's my outermost, right? Because I could rewrite this as this. Okay. For some reason, students always struggle. Let me just give you a little step sheet here. When you're doing derivatives of trig functions, you always want to do any exponent outside first. Then the derivative of the trig, derivative of trig. And then derivative of inside.
No, it's only Slade.
Why didn't you bring this out?
He wakes up, he just still wants it. He wakes up at his birthday and he just wants it.
Why would you not?
I would have never get on the bus. I don't know why he do that. No, listen, I make him walk to school if he wakes up after the bus. I don't know.
It just dawned on me that because they just emailed about a late bus. All right.
No, it was. Was that him just getting you? No, that was just. Well, he told me.
They have a sub down there. All right, what do I do first to find this? Yeah, to find this derivative. Furthest outside, work your way inside. All right, so the first one is the outermost squared, and then I've got the secant, and then I have the 3x. All right, 3. Oh, you're talking about the exponent too. 2, and then everything else stays the way it is. And it's to the first power now, so really that's irrelevant. Now what? The derivative of secant. So I did the exponent outside. Now the derivative of the trig part. What is the derivative of secant? Secant tangent, right? Secant. Yeah. No, you do not. Tangent. Right? Now you do the derivative of the inside. Well, you can kind of, since the argument is the same on all of these, you can clean it up just a little bit. 6. Now I have secant squared 3x plus 1 times tangent. Because I got 2. Yeah. The derivative of secant is secant tangent. So you do the exponent outside first, and all of this stays the same. Then you do the derivative of the trig function, which is this. And then you do the derivative of the inside, which is this.
What are you gonna ask to make it 3 days long?
Y'all might just get it. Y'all might get it quicker than other classes.
Yeah, I say you go 2.
Can we think we can stretch break? You know, in this class, the elementary school, like, new, they, she put totally on the board and then do a little extra. I think I would do very well. Keep our butt. Oh, yeah, that's what I'm telling. No. Yeah.
Find dy dx. Are you going to do quotient rule on this one? If you're a quotient person, he's going to do quotient rule on that. The rest of us are probably going to do power rule. No, there's no product rule there. Why? What does product mean? I wouldn't even go that far. Now that you know power rule, that's the point that I'm getting to. Now that you know chain rule, but now that you know chain rule, you don't have to FOIL these things out. You could, but you're going to have a lot of work. What I would do is I would look at this as 2 different functions. Something to the -2, and then all of this in here. So if I did chain rule, power rule first, -2. This is what y'all kept trying to do, but you couldn't do it. What does this exponent become? -3, because I got to subtract 1, right? But I can't stop there because I have to do the inside. That's exactly right. Close. You're right. 1 plus 1/2 Where are we getting that? Yes. This is the same thing as x to the 1/2. Could I have just distributed that -3 through there, or can I just distribute that -3 through there? No, I can't do that because I'm adding inside. I would stop there if it was me. If you care to continue on, you could distribute this through to this one, and maybe have -2 minus x to the -1/2. But I think that left the way it was just fine. Either one's fine. No, because multiplication, remember, you only multiply 2 at a time. How many embedded functions do you see?
4, 5.
Embedded, composed functions.
0.
I see 3 functions altogether, but I'm talking about applicable to the chain rule.
4, 5, 2, 3, 8, 5.
All right, look, this is multiplied. Actually, 2 sets of 2, but no more than 2 at one time. Okay. There's 4 functions. How many of them are embedded? There's 2 sets of 2. Right? Do you see that? Like, let's go through and do this. Does everybody see that this is a product rule situation? Everybody agree? Do you see why? Actually, let me not say that. Yes, but not just yet. Graphs never go away. We'll start curve sketching soon. It'll be such fun. All right, so if I find the derivative here, right, I've got to use product rule. What is the derivative of the first one? Yeah, so don't derivative both at the same time.
3.
Outside, you got to eat the lollipop before you eat the gum.
Oh, yeah.
3 sine x, but this is squared now, right? Because it's cubed here. So 3 sine squared x times, now I do the derivative of sine. If this had a derivative, I would do the derivative of that now as well. This is just the derivative of the first. Look at this. Let's imagine if this is u and this is v. All of this is derivative of the first. Then I multiply by what? V, which is tan of 4x. Why wouldn't I what? Because at that point, so this is, think about it like u cubed. If I found the derivative of u cubed, I would do 3u squared, right? And then multiply by whatever the derivative of that u was in the middle.
Why is it not split? Why is it not plus?
In a minute, I've only done derivative of the first times the second. I've only done half the problem, right? Now I need to do plus the first times derivative of the second. What's the derivative of tan 4x? Secant squared x, only instead of x, it's What's the argument? 4x. Now chain it times 4. So this is a chain. This is a chain, and this is an interchain. No, that's not a chain. This is a chain. Sorry. So yes, this is. So here's u, and all of this is derivative of v. So remember that trig, how we do power, right? If it's raised to a power, we do power, trig, and then derivative of inside. So power, and this stays the same. Then the derivative of the trig itself. And then if this had something hooked to it and I could take the derivative, that's when I would do it then. Yeah.
What's written under 4?
Chain. That's the chain. Right. Yes, right now. Clearly this is what we need help with. Let me do another one. That's the inside. So I've got, yeah. I've got derivative of the outside. I've got power, right? No. Derivative of tangent. There's no power there, yes? So derivative of tangent is secant squared. The argument stays the same. Then I have to take the derivative of the argument inside. See if this helps. The derivative of tangent squared u would be 2 tangent u. Then I do the derivative of tangent, which is secant squared, and then I would have to do the derivative of the u. Because I have to do power, trig, argument. That's my order. Power, trig, argument. Outside in. Rushing nesting dolls. No, are you? How is what? How is what? The derivative of u. That's where this 4 is coming from. Prime. That's not to the first power, that's a prime. Depending on what u is, it might not be. What if u was 5x? Then u prime would be 5. Yes. It could be a whole function. U could be whatever I wanted it to be. If it was tangent squared 5x, then it would be 2 tan 5x, secant squared 5x. And then what's the derivative of 5x? You keep, yeah. What's the derivative of tangent? Guys, I need y'all locked in. What's the derivative of tangent? So I brought the exponent around on the pink one. Why'd I do which part? If I took the derivative of tangent squared, this is what it would look like. So I do the exponent first. There's actually a little 1 there. So this corresponds to step 1. This corresponds to step 2. And this corresponds to step 3. Power, trig, argument. You're locked in or lost? What'd you say? Oh, good. Which one? Beside the two. These take practice. And so, yeah. Sure. The extra 5x. And which one? Which one are you looking at? This 5? This 5x? This is secant squared of 5x. This argument stays the same all the way through until you take the derivative of it at the very end. That's where I did the power. Look at this one. Most for tonight, yes. Find dy dx. Oh, I should have made this. Put a 3 right there. Yeah. Yes. You ready? All right, I got a trig function, right? And you're exactly right. That's one of those that I can pull out in front. All right, Sonny, I would appreciate if you would put that away, please. Whatever it is. All right, so the first thing I'm going to do is the exponent, yes? All right, I can pull that 5 out front. 20. Everything else stays the same, but the exponent goes down by 1. Sine cubed 3x. There's step 1, yes? Outermost. That's as far outside as I can go. Then I move a step inside. One more layer in. We really need those gobstoppers. Cosine 3x. Yes? What should be product? Yeah, it's cosine of 3x. The 4 multiplied to the 5 to give me 20. All right, so this is my step 1. That's my power. My outermost, because remember, this could really be written this way, and it might help you see it this way. So there's my power. Yep. This is my trig. Argument has to stay the same. And now I have to multiply by 3. We'll see. I'm just kidding. 3 is just the inside. Yeah. I'm going to start working through some of your homeworks with you. The 3 over, yes, for that one there, yes. Yeah. You don't do anything, after you do that power, you don't do anything else with that exponent. Oh, do y'all want a packet? Or do you want the book? I'll run you a packet in just a minute. I'll go run them. If you don't carry your book, I'm gonna, if you want to get started on your homework, I'm gonna work through several more problems. So if you're gonna work independently and quietly, please, while I help everyone else and continue to work through. I like to do this sometimes because if you're bored because you know how to do it all already, then go ahead. But please, 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 if you are unsure of yourself or not 100%, you need to pay attention to me working through them, because nothing ticks me off worse than whenever I work through 5 of them and then somebody is doing their homework and then goes, but wait, Miss McGee, I don't know how to do this, and it's one I just explained. Yeah. That's all your homework. 2 through 32 even. And I'm going to work through a couple of the harder ones now, I think. Yes. Let's do, what do y'all say? Pick one. Oh, by the way, on 1 through 8, let me show you how it sets it up. Like 2 says y equals sine of 7 minus 5x, and it says u equals 7 minus 5x. Just ignore that. Take the derivative of y. They're just showing you what the innermost function is. If it helps you, fine. If it doesn't, then... Ooh, I should have y'all do 5. I should have done odds instead of... We've actually already done 2 of the odds. So if you got them in your notes, it is a 2-second problem. Let's just do odds. Yeah, 1 through 32 odd. 1 through 31 odd. Do you have one? Do you want a book or do you want me to run you a copy? It doesn't matter to me. Are you sure? I don't mind let me get you a book too. I mean, I'll still make you copies, but you don't want to tote it around? Okay, I'll make you copies. Well, they asked me to make copies of the ones that didn't have the answers on them. Why don't you take a picture of my book with the answers, and then I'll run copies. That's just number 2. I was just showing, but now you're not doing number 2. Let's do 23. This is a great one because it's got a ton of functions embedded into it. Find dy dx. You're exactly right. So remember, you got to eat the lollipop before you can get to the bubble gum. I have said that for years, Dozier. I am going to keep saying it. No. You know what? You don't get any more of my lollipops. You're done. Cut off. Done.
On 3, on 3, all the way to x.
Just over the 3. Makes it easier too. All right, power rule first. 3, everything inside stays the same. Now I look at this as if I am just finding the derivative of the inside, right? Something before that. All right, derivative, I can separate because I'm adding, right? Derivative of 1 is just 0. What's the derivative of cosine? Yes. When I have a trig function that I'm taking the derivative of, it's power trig inside, always. Power trig inside. I've got a power here. So I need to do that first. So times, that's right, 2 cosine 7x. What comes next? Power trig. So what's the derivative of cosine? Negative sine. It stays the same. Now what? Or in other words, 7. I did this power outside here, but then there was a power inside. There were 2 different powers in this one. So if I clean it up just a little bit and put my constants, my coefficients in front, I've got a 7, a -1, a 2, and a 3. Negative 42. Is that right? What one? This is negative in front here. And then I'm literally just going to rewrite everything. Squared on what? Oh, I did, thank you. Negative 42 is from 3 to -1 and 7. Absolutely. 5's a great one. Huh. It's not subtracted. No, it's just one.
Where do you get the
Square root on the first one. The squared. There was a 3 here initially, so whenever it came around. Right, then you would just move to taking the derivative of the function. All right, somebody asked about 5. These are homework questions, yes. So make sure you write them down. No, I changed it to odd. 1 to 31 odd. Specifically, this is the one I wanted you to get. Close. Yes. So I'm still right. This is going to be an outside exponent and then the quotient rule inside. So all those other rules still come into play. So you bring out the 2. Now do the derivative. I'm going to give you all a second. Hi, I am not missing. All right. Derivative of the top. Derivative of the top times the bottom. Whoa, 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 whoa. I see. I'm going to still write it so that you. Derivative of the bottom. Wait. Derivative of the top times the bottom minus the top times derivative of the bottom. I did though. If this is derivative of the top times the bottom minus the top times derivative of the bottom. On your sheet it might say this, but it doesn't matter the order you do that in. So yes. All right, and then 1 plus, but this is nice because some magic happens here, I think. Yes, so this is going to be, all right, I've got 2. I'm just going to write this right here. Times, this is going to be cosine x plus cosine squared x plus sine squared x. And I hope you see the one thing that I told you to always see. Where, Miguel?
Cosine x plus cosine squared x plus cosine squared x.
If you do not recognize any other identity, always recognize that one. What? It's a derivative of that one. The derivation. It's the now I've got cosine x plus 1 over, what you taking out? Absolutely. That's what I would do. This is what I was talking about whenever I told you some magic starts happening, right? Cosine x plus 1 is the same thing as 1 plus cosine x. Or I probably just do that so I can see it a little better. Whichever, you end up with the same thing anyway. You got, and I'm going to put this 2 up top just because, why not? It doesn't matter. Over 1 plus cosine x. Yeah. That was a fun one. It was magical. It's kind of like whenever we're doing those rationals and stuff, everything started canceling out. It's very satisfying. Give me another one. I love to work these. 11. Is that the one you asked me about earlier, Logan? I don't want to work too many of them because remember, yeah. If you just watch me work them, it looks like it makes sense. My advice to you would be to go back even after we've done them together if you are struggling with chain rule and try to rework them, and then you got steps there to look at. Tell me when you're good. What? What? They're coefficients in front. It makes this problem look a lot worse than what it is. So it says that this is the position of a particle. Find the velocity. So just the first derivative. That's exactly right. So there's no power. Remember, power trig inside. Okay, don't look at this as a function. That variable doesn't count as the variable that we're taking with respect to. This is just a constant out front. So 2 and 2, right. So do the first one first, because I'm adding in the middle, so I can separate them, right? Take the 4 over 3 pi out. What's the derivative of sine? Cosine. The 3t stays, though. When you do the trig, that argument stays. Then I chain it. That's exactly right. Then I do times 3. Right. So I got 4 over 5 pi. Derivative of cosine is negative sine. And I'm writing this out. If you just change that to a minus, that's perfectly fine. Derivative of 5t is times 5. Now, the reason this problem is kind of cool, the 3 and the 3 are going to cancel. The 5 and the 5 are going to cancel. So I end up with 4 over pi cosine 3t minus 4 over pi sine 5. If I wanted to take a 4 over pi, factor it out, I could as a DCF. You don't have to. That's too much. But no, but if it was a multiple choice question and one of your answers looked like this, could you recognize, hey, that's the same thing? They just factored out a 4 over pi. So not necessary for you to write, but necessary to be able to recognize. No. Yeah. Notice 29 and 31 ask you for a second derivative. Yeah. Oh. Oh, dear. No, it's just find the velocity. It's just first derivative. It's constant. Derivative constant is 0. Second derivative. What's the first derivative? What's the derivative of tangent? Secant squared. Second derivative. Now I have a power, right? Power trig inside. Power 2 secant x trig secant tan, and then inside, but the derivative of x is 1, so that doesn't do me good. So the second derivative would be 2 secant squared tangent. Let me